sometimes we have to say whether there exists some correlation between input predictors and the output. Okay, how can we define the correlation? How can we say the answer? Let's start by a simple single predictor case, right? So, sorry, I will use black. So there is this simple model, and we have to say whether beta 1 is equal to 0 or not. Okay, how can we say this? If you take the course Engineering Statistics, you know the answer from the t-distribution and p-value. We can make the answer probabilistically. Okay. What is t-distribution? Essentially, when you know the true variance of beta 1 hat, beta 1 minus beta 1 hat over variance of beta 1 hat follow the normal distribution with mean 0 and variance 1. Of course, we need some assumption, a very important assumption. Epsilon is a normal random variable. Okay? When epsilon is a normal random variable and independent to every training data point, we have this beta 1, the true beta 1 minus beta 1 hat obtained from the training process by minimizing RSS value, follow the normal distribution, and when we normalize by the variance of beta 1 hat, we will have a normal distribution with mean 0 and variance 1. So from this, we can do something interesting because we just need to check whether beta 1 is equal to 0 or not. We just put beta 1 equal to 0 and see the value. What is the minus beta 1 hat over variance beta 1 hat? If the absolute value of beta 1 hat over variance of beta 1 hat is huge, then because we assume that, or because we know that the true beta 1 minus beta 1 hat minus variance beta 1 hat follow normal distribution 0 and 1, because we know some tail distribution of the normal distribution, we can give you some probabilistic value. When beta 1 is really 0, the probability beta 1 hat current value appear. Okay, when you put beta 1 equal to 0 for this equation, you can basically understand the current event probability. Okay, but here, what is the problem is why we have to use t-distribution instead of normal distribution is we don't know variance of beta 1 hat. To know the variance of beta 1 hat exactly, we have to know the variance of epsilon. The variance of epsilon can give you the variance of beta 1 hat, but the problem is we don't know the variance of epsilon. So we have to guess. We have to estimate the variance of epsilon from the standard deviation of the model. From the training data and your trained model, you can understand standard deviation of beta 1 hat empirically. Unfortunately, but there is some error. We cannot compute, we cannot obtain the exact sigma value from the training data point. This is not zero. But this is very long-standing problem, and many statisticians have worked on this topic, so they invented a new distribution called t-distribution. Okay, so essentially t-distribution just replace the variance of beta 1 hat by standard deviation of beta 1 hat. Then this follow t-distribution with degree of freedom n minus 2. Sorry, because there are two parameters. The degree of freedom is n minus 2. So again, to check whether beta 1 is equal to 0 or not, we just need to put beta 1 equal to 0 for this equation. So you just need to check the absolute value of beta 1 hat over standard deviation of beta 1 hat. And from this value, you can look at the p-value table. And the p-value table can give you the probability the current event comes from the beta 1 equals 0. So you can say that the probability of there's no correlation between x and y. Okay, then what will happen when there are multiple input predictors? Okay, again, from the course on engineering statistics, we already know the result. So previously, we can use t-distribution and p-value. When there are multivariate linear regression, we just need to use F statistics. F statistic, the definition is this: total sum of square minus residual sum of square over P and residual sum of square over n minus P minus 1. So this is very well-known ANOVA technique, analysis of variance. Why this is a good indicator to understand whether there exists correlation between any predictor and the output value. So imagine when there are no correlations, so beta 1 equal to beta 2 equal to beta p equal to 0. Then what will happen? What will happen? Then this essentially follow chi-square distribution with degree of freedom p. And this value follow chi-square distribution with degree of freedom n minus p minus 1, essentially with scales over p over n minus p minus 1. the expectation value of this is equal to 1 and the expectation value of this is equal to 1. So when there are no correlation between input and any predictors, then we can say that the f value will be very close to 1. So when your f statistic value is close to 1, you can say, well, there is no correlation between input and output. If the f value is very huge, you have to say there is correlation. Okay? So because you already studied the T statistic, F statistic in engineering statistics course, and that was our prerequisite story, I will stop here. But welcome any question on this.